So this is a renewable energy system that I designed for my final year project. Basically, the idea came from I had worked in on Intra with an ESB and that, and I had become interested in power electronics. So while there, I was talking to so many engineers, some possible possible projects I could do, and one of the ideas was kind of offload storage for renewable energy. Now, while they would have meant on a grid scale, I decided to go more small scale and design a prototype for a product you could put on your house. So basically, you'd have a solar panel or some form of renewable energy source coming in and powering your battery. This battery then uses the energy harnessed, and it powers a circuit in here. Now, the circuit is it's controlled by an Arduino board. That Arduino board is taking readings from an LDR circuit, which senses the light intensity in the room or outside, as it would be in the house. You have two switches. Then one has like a manual override, and then one is it gives you a power saving option. So what the manual override is that while this is checking your light intensity, when it gets dark outside, you can see the lights come on in the house. So your lights would automatically come on when it gets dark out. But obviously, sometimes it's bright outside, but it's dark in the house. So I had to build in an override that you could just turn on the lights yourself. So that's how that works there. Now, the power saving option was, as you're dealing with a source that's kind of limited power, that it's going to eventually run out. I decided I'd try and extend it. So I decided to kind of look into the idea of the way fluorescent tubes are pulsed at the moment. So if you use a DC circuit and there's a little timer circuit you can use. What it does is it can flash your lights at a rate of, well, in Ireland it would be 100 hertz because you're dealing with 50 hertz main supply, or in America it's 60. So this is about 120 hertz, but once it goes above 50, you can't actually see the flashing of the lights anymore. So it doesn't affect your users' comfort while using the product, but it means that you're prolonging the life of the battery up to double the time, because while you can't see it, it's on half the time and it's off half the time as well. So basically, you have your choice between whether you want it directly coming from the battery or you want your timer to flash your circuit. And as you can see, while it's being flashed, it doesn't affect how it works. And that's basically how the idea of the project. And the application for this is, as I said, it's for a house by house basis, and it's designed that you can retrofit it to an old house by connecting straight to their circuit board, because in most houses now, if you have the new circuit board, your lights are on a separate circuit, so you can use the pre-existing cables in the house, or in a new build you could implement a circuit with new cables, and you'd be able to utilise the DC operation more so, whereas if you were going into a house, you'd put an inverter on this and you'd use your AC, which you'd lose your power saving option, but you would be still able to use your automatic light sensor. So that's the kind of where it came from and the work I did. Thanks very much.